Welcome, everyone, and thank you for joining us today. My name is Christy Constantine, an account manager at SIMCO Electronics. We're excited to dive into the critical topic of minimizing calibration out of tolerances, also known as OOTs. With us, we have two fantastic speakers, Trey Eason, a seasoned metrologist with deep technical expertise, and Walter Kromm, SIMCO's Vice President of Customer Success, who brings a unique perspective as a former calibration technician now focused on customer partnerships. Together, they'll help us explore OOTs from both a technical and customer experience angle. Welcome, Walter and Trey. Thanks for joining us today.
Thanks, Christy. Happy to be here.
Thanks. Great to be here.
Trey, let's start from the basics. From a metrologist perspective, why are OOT events such a critical risk in regulated industries like aerospace and medical devices?
Well, to start with, the requirement is based out of ISO 9000 or ISO 9001 or AS 9100. Both those industries you mentioned are regulated and typically tend to follow those requirements. And the gist of it is that the organizations have to go back, look at the history of any device that took a measurement that was found to be out of tolerance, and make sure that it didn't change any of their past failed decisions, or it didn't require them to possibly recall something that was accepted with maybe bad measurements.
Thanks, Trey. That gives us the technical side. Well, from the customer's viewpoint, how does an OOT affect compliance and the trust customers place in SIMCO?
Yeah, it's a fantastic question. I know with regulated customers, OOTs can be stressful in the business, could lead to production being stalled or product recall to be initiated. So when customers get an OOT, they want to be assured that it's truly an OOT. And at SIMCO, what we did was we make sure that there's a second layer of validation that happens in a lab when we have an OOT. So, for example, if a tech comes across an item where we have a reading outside the tolerance, they'll go and seek advice from another technician or the manager to validate the OOT to make sure that when we do release an OOT alert, that it's factual and they can rely on it. Because if we don't have a second layer of assurance, the possibility of pushing out a false OOT can be there. So we want to minimize that, mitigate it with a second layer of validation. So that helps build trust. Customers know that there's a second set of eyes on OOTs to make sure that, yes, we are confident that the item is out of tolerance. And then the customer can go about their business of doing the analysis for any kind of impact.
Thanks, Walter. Trey, due to the critical nature and potential impact arising from out of tolerance events, what practices separate organizations that are top performers?
So first of all measurement equipment will drift over time. So it's an inevitable fact that you're going to have to deal with an OOT if you're doing any calibration. Organizations that understand this and take proactive measures can get ahead of the curve in dealing with this. So you do things like record data, report, analyze, and use that data to make adjustments to the intervals. There are standards out there like the ILAC G24 and the NCSL recommended practice RP1. Those provided great guidelines for those who already have a technical background to make adjustments. Some industries also are sort of forced into accepting certain calibration intervals or certain guidelines based on the industry they're in. They're in particular, the aerospace industry has some rather strict guidelines for oven calibrations, temperature controllers, and pyrometry. So another thing that the organizations do is make sure that they have proper handling, storage, and preventative maintenance. Careful use, transport, storage extends the reliability of your equipment and prevents premature OOT events. You can also do intermediate checks in between calibrations. A lot of people call these bump tests. But if you use them, you can detect drift early and potentially catch things and provide. The other benefit is that if you do have an out of tolerance, you can always just go back to your last bump check because that gives you a good starting point as to when it actually started to go out. A couple other things to keep into consideration are your decision rules. Organizations must decide, what their own risk tolerances are. And in some cases, your decision rules are going to have an effect on your out of tolerance frequencies. So, the more strict your requirements that you set for your decision rules, the more likely you are to have out of tolerances more frequently. Then you could also do limited calibrations, adjust tolerance limits. And then eventually, there comes a point where you're starting to see enough OOTs that it's costing you enough either in calibration or repair that you may want to even consider proactive replacement.
Trey outlined what best in class looks like. Walter, how do customers react when they learn where they stand compared to these benchmarks? Does it change the conversation around investment and calibration?
This is a great set of recommended best practices, and I'm not so sure that our customers realize how many opportunities there are for them to reduce OOTs by just adopting some of these best practices. The one that jumps out to me is the bump test that Trey alluded to, the intermediate checks. If you have an interval of 12 months and something is out of tolerance, well, you'd rather not have to go back 12 months and look to see what the impact was. If we did bump checks or tests maybe every month, you can minimize the impact. And I think for customers, we can help educate them within our organization. Our charter is to help customers improve their business by reducing waste and creating efficiencies, driving out cost. And if we can help them drive out cost by eliminating OOTs, because there is an impact and a lot of time is invested in the analysis, that'll drive, I would say, a customer that relies on SIMCO to be a leader with best practices and, not only be an SME on calibration, but be a coach, a partner. And, that's what we're looking to get accomplished within customer success. OOTs around torque are probably the most prevalent area that we see that customers can drive down OOTs by just including a bump test in their daily practices, if not weekly. So great set of recommended practices, and customer success will probably look at these and share a lot of these with our customers. And I think that's going to go a long way to driving out waste and cost in programs. So great set of best practices, Trey. Love them.
Agreed. One of the best practices is proper handling, storage, and shipping. From your experience, Trey, what are the most overlooked mistakes that contribute to OOTs?
So, things I've seen in the past are I've dealt with customers who didn't understand the importance of storing things in temperature controlled environment or vibration free environment, or sometimes even the daily maintenance of cleaning and putting things back in the cases that they came in. Another given one is the storing calipers with the jaws completely closed, where you have metal to metal contact. So it all depends on the specific piece of equipment that you're looking for and the sensitivity of the equipment that you're working with. But primarily, the biggest thing I've seen is the customers not being aware of the best care practices for their equipment. They may not have read the manual. They may not have somebody who's been around as long enough to remember where the manual even was. And so if you're not taking care of it on a daily basis, chances are it's going to eventually, just like your car, if you don't take care of your car, the tires fall off and the engine quits running. The same thing happens with your gear.
So, Trey covered what happens if we don't handle properly. Walter, how do you translate that to customers so they see protocol handling as long-term cost and downtime saver rather than an extra hassle?
I've spent a lot of time calibrating in environments, in customer settings, in a production environment where they might have calipers and micrometers just out on a surface plate or on a bench or table or cart, and they're not in their protective case, and they just get used in an environment that is, well, it could be dirty, high humidity, It could be in a machine shop setting where you've got a lot of metal shavings that can get into the gears. And if customers could just try to keep the case and the instrument together and consider just one, it'll extend the life of the asset. It's more prevalent in environments where you're dealing with a lot of hand tools, torque, calipers, mics. They all come with a case, and more often than not, customers separate the item from the case. The case goes somewhere in maybe a bin or a cabinet, and the instrument is out in an environment that may not be conducive to long-term reliability. So again, this is an opportunity for customer success to help customers drive out or eliminate waste, replacement waste, if they can just handle their equipment more appropriately. And this goes for SIMCO too. When we calibrate and we deliver, we should make sure the item goes back in a protective case or carton so that when the customer gets that item back, they've got high confidence that it was handled properly and the calibration supports the long time use of that asset. So it goes both sides, both customer use and also SIMCO handling is paramount to reassuring the customer that the calibration was done properly and effectively.
Calibration versus post-calibration adjustments can be tricky. Unnecessary adjustments may actually increase OOT risk. Trey, can you break this down?
Well, yeah, there's kind of an old saying that goes, if it ain't broke, don't fix it. And the same thing kind of applies to, measurements and calibration. There's some things within tolerance and well within tolerance, within, guard banding guidelines or whatever. Uh, there's a risk that's involved with making an adjustment that the customer should probably have a discussion with their calibration vendor about. Is it a higher risk to make an adjustment to try to get something perfect versus accepting it where it is, knowing that it's not drifting historically or something along those lines? And again, this is going to be a case by case decision in many cases, because what works for one piece of equipment may not work the best for another piece of equipment. And the same thing goes for the same piece of equipment for two different customers. But you want to assess the risk and make sure that it fits your own risk posture before you make an adjustment. Every time you turn a wrench, every time you turn a screw, every time you turn a pot, there's the risk that you're going to make things actually worse. And early in my career, I can tell you I spent a day or two on one or two pieces of equipment that I probably shouldn't have tried to adjust that did, and then I had to get it back in working order.
Trey showed us the technical nuance of adjustments. Walter, when you talk to executives who may not be engineers, how do you explain why decision rules and careful adjustment policies are worth the effort?
Yeah, great question. I've seen customers look to have their instruments optimized whenever they come in for calibration. And that might look like if it reaches 70% of its tolerance, they would like us to optimize and nominalize the reading or the performance of the instrument. But when you do that, you're actually impacting the instrument reliability, the performance, you're stressing components, both electrical and mechanical. So although it might seem wise from one perspective to optimize whenever you can, you might actually inadvertently cause more OOTs as you stress components by repeatedly adjusting a potentiometer or a mechanical component whenever something's at or near the limit. So it's not always the best practice to optimize. You're better off letting the instrument behave the way it was designed to behave, adjust it only when necessary, and it gets back to the earlier question we covered around care and building in some periodic checks. That's better than optimization. Again, components, they stress over time, and you can actually create more harm than good.
Fixed intervals can sometimes fail. Short for some tools, too long for others. How should organizations use data to adjust intervals proactively?
So, and I believe I mentioned it a little bit earlier in this discussion, but there's several guidelines or recommended practices out there. The ILAC G24 and the NCSL RP1 are the two most widely accepted ones, and they provide a pretty good technical background for how to how to make decisions based on whether or not you want to adjust your intervals, whether you want to increase it, decrease it, etc. Um, and they're a great resource. We can also provide access to digital tools that are already built in to like CERDAC, because there's software packages out there that will do the same thing.
Great technical insight, Trey. Walter, how do you help customers see interval adjustments not as an added complexity, but as a way to save money and reduce surprises?
Yeah, I think sometimes customers think they have to manage the interval analysis. They don't have to. We have the ability with the algorithm from the NCSL RP1 to electronically call it, set the interval analysis program to activate per asset if that's required. And it happens without the customer having to interact at all. The technician might find something out of tolerance, and the interval will get increased or decreased according to RP1, and automatically the due date gets reset and the interval gets changed accordingly. So it's really a hands-off operation relative to the owner of the instrument, and everything's auditable. If a customer wants to know if something was changed, we have the ability to go back and take a look at when and why that interval was changed, and it all would point back to the NCSLI RP1.
Fixed intervals can sometimes fail, short for some tools, too long for others. How should organizations use that data to adjust intervals proactively?
All right, I think I love this question most of all around decision rules. It's up to the customer to define decision rules and for SIMCO to deploy those rules. In the case of OOTs, we have the ability, based on the NCSL RP1, to adjust the intervals based on certain criteria. It can be customized. And once the customer makes a decision about instruments, either individual or class, we can activate the algorithm and the intervals will be adjusted based on performance, and the technician will be able to complete the cal with the algorithm making that decision for him or her as to whether the interval is going to go out, increase, or down, decrease based on the performance history. So after the decision's made, the technician and the work that's done in the lab is really hands off as it relates to the customer. But initially, the decision has to be made, and careful consideration that an interval being adjusted, although might seem beneficial, in some cases could drive up the cost of calibration if it's shortened to a point where you're doing it several times a year. And at that point, maybe it's unwise to do that for a certain class of instruments that don't have good reliability. So you might want to pick and choose which instruments are best to assign the interval adjustment program for.
Thanks, Walter. Trey, can you share an example of limited calibration where focusing only on critical functions actually reduced OOT risk?
Yeah, actually, I had a customer a while back that had a specific brand of photodiode power sensors. At the time, I noticed that we were failing or had a roughly 60% OOT rate when we were sending these out to the vendor for calibration. Uh, Over time, the intervals had gotten reduced to 3 months, and these things took about 6 weeks to get calibrated. So, half of the time they were around, they were being recalibrated. So we dug into the history on them a little bit and found out that out of all the OOTs they've had, the customer reported back that it never had an impact because it wasn't the OOTs weren't even occurring in ranges that they were using. So this became a study just to verify with the customer and take their input, and we determined that we're not gonna not calibrate them in those extreme ranges. We're gonna give it a much larger calibration tolerance. And as a result, they started, we went from a 60% OOT rate down to about a 5% OOT rate. And everything that they needed it for was being calibrated, and they were still even able to monitor the extreme ends with the expanded limitation on the calibration. So it's kind of a win all the way around.
So Trey showed us the efficiency side. Walter, how do customers respond when they learn that sometimes less calibration, if applied strategically, actually gives them more reliability?
Yeah, I think when customers buy test equipment, they're buying something that may provide measurement capability far beyond what they need it for. So we might come across a calibration and an out of tolerance condition that's just not having any impact on somebody's business. So that might be considered like a nuisance OOT. And what we can do is we can provide a limited use or calibrate something to customer specs, with the caveat being is that if that asset is not properly labeled or controlled in some manner, you could have something that is limited use for one application, but maybe it's being shared within a facility, and another user might use that range that was not calibrated. And then you've got an issue where you've got some potential recalls, right? Where you've got something used that's not actually calibrated. So proper labeling is key. The database has to be, of course, connected to the labeling so that if the label states something is limited use or count the customer specs, the database has to match that. So there's visibility from an audit perspective, but really critical that the labeling has to be really clear and exact as to what was counted and what was not, so that the item would not be used in a manner that could negatively impact the use. So yeah, again, a little bit tricky, and it usually is common in a facility that has a large inventory of common assets that just migrate easily from one hand to the next. Again, having good control practices is key.
Thanks, Walter. Trey, from a technical standpoint, what signals tell you that it's time to retire an instrument rather than continue recalibration?
I would say it's not usually strictly technical that causes those decisions to be made. Um, a lot of times it winds up being a cost versus risk kind of situation where if through the interval analysis you've gotten down to a frequency of calibration um, that is costing you more than it would to actually to purchase another piece of equipment, or if the repair cost reaches certain thresholds. The biggest thing that you're wanting to do though is see that at the end of the calibration interval, that piece is going to still be in tolerance when you're using it. So if you haven't found a reliable, if it's out of tolerance at 6 months and then you cut it to 3 months and then it's out of tolerance again at 3 months, at some point you've got to just balance your own risk and determine, okay, I don't think this thing is reliable enough and it's costing me more money to calibrate on a daily basis than to just buy something that's more reliable.
Yes, that's the metrology side of replacement. Walter, when it comes to customers, how do you frame proactive replacement as a smart investment rather than a sunk cost?
Yeah, there's hidden cost when intervals are so short. It's not always clear because customers are always worried about the financial impact of investing in replacements or repairs. But if you're dealing with something that's on a 3 month or a 1 month interval, the reliability is not there anymore. So there's a risk in that, and I think you've got to be able to balance, your acceptable risk with the economics of the instrument. We tend to kind of coach customers to maybe look at identifying a percent replacement cost when making decisions. It might be 50% of the repair or the replacement value. If it's 50% of the replacement cost, just get a new asset. Especially true with things that are low cost. You can get them replaced a lot cheaper than a repair. But it's an issue where you've got to be able to have a wide perspective on your risk tolerance versus the economic investment. And I would say that it's really case by case or class by class of instrumentation and the use of it. They all play a critical role in making that decision.
Trey, how can software like SIMCO CERDAC help with monitoring trends decision rules, and audit readiness from a metrologist perspective?
CERDAC provides a centralized point for data collection, has dashboards so that you can see trends in real time, assists with scheduling and coordination. It's kind of a one-stop shop. It provides notifications for things like gauges that are coming due or out of tolerance instances. So it also has a central location to store impact assessments for out of tolerance instances. So organizations preparing for or currently in an audit can also pull up any historical data since it has been calibrated as long as it's been being tracked in CERDAC.
Thanks, Trey. And Walter, from your side, how does this digital transparency change the customer's experience during audits, especially when regulators are in the room?
So CERDAC has been, I think, about 30 years of existence, and it's evolved over time quite rapidly recently. It's a validated asset management tool. As long as the information that's entered by the technician is accurate, and it usually is, then the data that's represented in CERDAC is equally as reliable. It also allows an auditor to be able to assess with relative ease the health of the program by looking at a series of dashboards that we've got available, with turnaround time being one of them, OOT rates, repair percentages, but anything you can really want to see, compliance-related information, items that might be overdue, items coming up for calibration, the recall. So everything's in one place, really concise, laid out quite well, and is compliant. So it really is for auditors a lot easier when they're working with a database like CERDAC to feel comfortable and confident that the information is accurate and providing a lot of care and control for the user.
Agreed. Trey, if a company can't implement all 10 best practices at once, which one would you advise that they prioritize first?
Personally, I would start with the interval analysis and adjustment. Basically, the data should already be there. You can already catch a better calibration interval for a higher reliability based on the data you currently have. Then, as you work in the other things, the bump tests, the better protection and storage and handling, etc. As those things increase the reliability of your equipment, your interval analysis is gonna grow with it, and hopefully you'll wind up in a better situation eventually.
So Trey just gave us the technical starting point. Walter, how do you help customers phase in improvements so they don't feel overwhelmed or disrupt operations?
Yeah, Trey, I would agree. If customers could adopt an interval analysis and adjustment program, that's based on, a scientific approach to maintaining high reliability, it is a really cost-effective program. Not many are aware of it. It's up to us to kind of help the customer understand the benefits of interval analysis, and also show them that there is a benefit due to the reliability that you're going to gain, and eliminate a lot of unnecessary cost relative to OOTs. So of the many available options for customers to adopt to help them improve their program, that's probably one or two of the most important, most impactful attributes. So I would say, yeah, Trey, I would agree with you. And it's not going to disrupt an operation. It really happens behind the scenes. So as I mentioned earlier, it's largely hands-free.
Walter, can you share a success story where SIMCO helped a customer significantly reduce out of tolerance rates, and what did that mean for their business?
Yeah, just recently I was working with a customer and they were coming up with a high OOT rate. And we did a bunch of research on the specs that were published by the OEM. We looked at the website and looked at the specs that the customer was then using internally. And what we came away with was that there was a difference in the printed specs and what was available online It turned out that they were not connected. There wasn't an update meant or made to the manual. And the Cal Lab had the manual, and the customer was looking at the online specs, and we had to figure out which was proper. And we found out that the published specs were wrong. And that then pointed us to, okay, we need to be updating our records more readily. When you are not on distribution for manuals, like those in the military are, it's up to the technician to be proactive to make sure they've got the latest manual on file and compare that to the specs online. There's also the marketing spec. So when customers are marketing their instruments, they want to be as aggressive as possible to sell that product. So their specs might be more aggressive than the printed spec or the spec online. So you can come up with, even a third option. It's really about managing the OOTs and doing the root cause analysis to find out, why do we have a high rate? Is it based on specs? Where are the specs coming from? Are they right or wrong? And then make sure you build in the best practices to make sure that what's used in the future is the most current. That helped us reduce the OOT rate for this one example I'm giving you by 30% for calibrations that were very expensive. So it's really meaningful to make sure that both the customer and the Cal Lab are working from the same sheet of music.
Thanks, Walter. Trey, after hearing Walter's story, what is the one technical takeaway that you'd want your audience to remember as they work to reduce OOTs in their own organizations?
Let's start with, in a perfect world, there would be no error in measurements or OOTs. However, being aware of the things that actually would cause an OOT, such as many of the things we've already discussed and some of the, things that Walter pointed out, things that I've seen in my history. So being aware of these types of things can help you to reduce or minimize the impact and save you time and money. So it's not just technical, it's about time and money and risk.
Thank you both, Trey and Walter, for sharing both your technical precision and the customer impact sides of this important topic. For everyone attending, please remember that you can access the full ebook for the detailed best practices. And of course, SIMCO's here to help you move forward towards the best in class out of tolerances performance.